So on the same lines, Calista, what does the future hold for us when we talk about RISC-V? If there's any inside information that you'd like to share with all of us.
We are absolutely honored and humbled to see so much growth across the compute spectrum. I think the difference between RISC-V, in addition to the amazing technical freedom and design freedom that you have, the explosion in opportunity, is that, RISC-V really fits across many different types of implementations. So, considering that and having the knowledge to be able to bring to your teams, to your development partners, to your management, to everyone around you, having the knowledge to be able to understand how that microprocessor design could be realized differently or better with RISC-V helps you make great strategic, long-term, durable choices. We don't have the luxury of software design where you can change your mind, you can issue a patch. We need to get as close to perfection as possible before you go into production, before you go to the fab. And that's something that, we are doing together as a community. By keeping everything open, you can design together with your other stakeholders, with your supply chain, with your development partners, and do so in a community, in a forum that still allows you to be wildly competitive and successful, as we've seen with Andes, as we've seen with Sci-Fi, as we've seen with Maven Silicon, that allows you to really kind of bring things to the next level. Being successful in microprocessors or in any business is not about making small incremental improvements. That's not going to get you very far, very fast. Making leaps forward is how you're going to be competitive and how you're going to realize the incredible promise that you have with RISC-V. So, the things that we're doing and that we're seeing in RISC-V that point to a very bright future is the incredible growth that we're seeing in our community. I mean, we grew last year 132%. We grew the year before 131%. I mean, these are amazing growth. Like, most people like to grow 3 to 5% a year. We are multiplying ourselves in our community. We have, around 12,000 developers that are engaged in RISC-V today. We have more than 2,700 members. You need to engage in that community. You need to be part of that community. We have more than 60 different technical work groups going on right now. That is an amazing complement to the education and knowledge that you get from organizations like Maven Silicon, right? Take that learning and go work shoulder to shoulder with your peers in the industry. Go work side by side in these communities to really kind of foster your own knowledge, continuous learning of your own, as well as to build your network. Because the stronger your network and the stronger those relationships grow, the more strategic for you personally in your career and the more strategic for your organization. So, my hat tip and my gratitude to Maven Silicon for the amazing level of training that you're providing. I mean, 200 engineers, that's incredible. And by doing that, you are fostering that success, that opportunity for those engineers to make smart choices for their careers as well as for their organization.
Great. Thank you so much, Calista. That was really, really kind. And Shiva, would you like to add to that? That what are our plans with respect to RISC-V when we talk about any upgrades in the curriculum or the way that we've been doing things until now? So yeah.
Yeah. So before getting into our plans, how I visualize the future of RISC-V, engineer's perspective, it's different. See, what we are looking for is something like new things will happen, new applications will demand new kinds of processors. Of course, there will be new threats, security challenges, And if you look at how things are going on, right? We started off with RV32i, RISC-V 32i, and then later on 64 became popular, but nobody knew that whether someone would be using 64 extensively, right? But today we are using it. So definitely in future, RV128, RISC-V 128 bits will also be used. We would be using that extensively for different kinds of applications. But the most important thing for us, for engineers, we are looking at something like industry standard ISA. That's what's going to happen. So RISC-V will emerge as open industry standard ISA. No more proprietary ISAs. This happened in our industry also. In my career, actually, I have been dealing with proprietary languages, IEEE standard languages also when it comes to verification. Today, if you look at System Verilog has become so popular. Everyone is talking about System Verilog. Even people like Calista also might be comfortable with System Verilog, the term. Why it has become so popular? Because it has become IEEE standard. People love to play with standards, right? Not proprietary stuff. So I think moving forward, we don't want to deal with too many proprietary ISAs. Currently, if you look at different companies, different organizations may have proprietary ISAs for specialized processors. So that's where RISC-V is going to emerge as industry standard ISA, and there will be one ISA, and then people will create their own extensions if they want to customize the processor, or they can even customize the base ISA also as they prefer, right? So that's going to be the future. When it comes to Maven Silicon, we want to upgrade our courses. There have been so much demand for RISC-V based courses. We need to add some more topics. For example, RISC-V processor design, we want to introduce topics like complex pipelining and low power mode. We want to explain more about compilers, debuggers. So there could be many more topics. That's how the course is going to evolve. Also, we are looking at creating master programs like designing system on a chip using RISC-V. How about that? So we want to provide something like a course for 1 year, course for 2 years, rather than looking at short-term courses. Only for RISC-V. So they will learn the basics. They can learn how to use all the fundamental blocks to create RISC-V processor. And then they will be working on all aspects of RISC-V, complex pipelining or low power mode implementation. It could be anything. And then using RISC-V processor, how they can build any kind of SoC, system on a chip. For that, they need to understand everything about SoC, how basically we use different kinds of IPs along with processor. So they need to be familiar with some of the protocols like SPI, UART, and how we build the bus fabric. Which one would be the right option? Can we go with AMBA? Then there would be different flavors like AXI, AHB. Then how to design different kinds of bridges. Then how to put all the things together. Of course, they need to understand other things also like pin multiplexing and then general purpose IOs. There will be system controller, how basically we generate clock. They need to understand analog components also. But if they can create even a simple microcontroller, that would be great, embedded systems controller. And that's going to be based on RISC-V processors. That's how our course is going to evolve. That's what I wanted to share with even Calista also.
Wow. I think that's a very, very massive and elaborate plan, I would say, Shiva.